Algebra 1, Factorisation. So in this section, when we're looking at factorisation, there are basically going to be 5 types. First one is where we have the highest common factor. Second one is where we're going to be grouping terms. Type 3 is where we're going to be looking at the difference of 2 squares. Type 4, sum and difference of 2 cubes. And type 5 is going to be quadratics. So in this video, we're only going to be focusing on type 1 to 4. So you'll need to do the follow-up video to look at type 5 quadratics. So for type 1, the highest common factor, what we need to do is look at what is the biggest number that divides into all of the terms, and we're going to take that outside the brackets as the highest common factor. So if we look at the first example here, we have 3x squared minus 6xy. So the biggest number that divides into 3x squared and 6xy is 3x. So therefore 3x is our highest common factor. And if I look at, well, what's left behind, well, in other words, what multiplies by 3x to give me 3x squared? Well, that's x. And what multiplies by 3x to give me minus 6xy? Well, that's going to be minus 2y. So now I am fully factorised. These are my two factors. 3x multiplied by x minus 2y will give me 3x squared minus 6xy. If we look at the second example there, we have 4 pi r squared plus 6 pi r h. So highest common factors don't always have to be in terms of x's and y's. They can be in relation to anything that is common to any number of terms. So the biggest number that divides into both of these terms is 2, but also pi and also or. So in other words, 2, pi and or are common to both of these terms. So I factor that outside the brackets, which then leaves me with what multiplies to give me 4 pi r squared if I multiply by 2 pi r. So in other words, if I multiply 2 r by 2 pi r, I get 4 pi r squared. And if I multiply 3h by 2 pi r, I get 6 pi r h. So type 2 is grouping. So often what happens is when I look at all of the terms in a given expression, I can't find a highest common factor for every single term. So when this happens, what we do is we tend to take 2 terms at a time and find that there is a highest common factor between each of those 2 sets of terms. So in other words, if I look at this example here, 3x squared minus 3ay squared minus 4bx squared plus 4by squared, there is nothing common to every single term there. But if I focus on 2 terms at a time, so the first 2 and the second 2, well, now I can see, well, between 3ax squared and minus 3ay squared, well, 3a is common to both of those terms. So if I take out 3a, well, that leaves me with x squared minus y squared. In other words, if I multiply out my brackets, 3a by x squared gives me 3ax squared, and 3a by minus y squared gives me minus 3ay squared. Now, if I look at the next 2 brackets, minus 4bx squared plus 4by squared, again, I can see there is something common to both of those terms, a 4 and a b. Now, this is where we have to be careful, because if I take out a plus 4b, well, then that will leave me with a minus x squared and a plus y squared. But I need to take out a second highest common factor. And at the moment, there is nothing common here. So I know I've done something wrong with my sign. So I have to go back and I look at the 4b. And instead of taking out plus 4b as being common, I'm going to actually take out minus 4b as being common. So therefore then, what is going to go inside the brackets? Well, minus 4b by x squared is minus 4bx squared. And minus 4b by minus y squared is going to give me a minus by minus, which is plus, in other words, plus 4by squared. So what we're always trying to achieve here is that what's inside these brackets is going to be the same. And that allows me then to take out the highest common factor when I've grouped my terms, and then the highest common factor a second time. So we're taking out the highest common factor by grouping 2 sets of terms at a time. And once I've done that, I take out the highest common factor, which is what's inside the brackets. So by taking out x squared minus y squared, Well, that now leaves me with 3a and minus 4b. Now, what's interesting about this one is that you might draw a line underneath that and say, I'm finished, I'm fully factorised. But inside this brackets here, we have an x squared minus y squared, which is going to lead us nicely into type 3. So this is actually called the difference of two squares. And therefore, I actually have not fully factorised there. And we're going to come back in 1 minute once I show you the formula, and we're going to fully factorise that equation. That expression, I should say, sorry. So type 3 is the difference of two squares. So when we see we have something squared minus something squared, well then our answer is going to be x plus y, x minus y. So in other words, if I was to multiply out those brackets, I get x squared minus xy plus xy minus y squared, and therefore that leaves us with x squared minus y squared. So when we're using the difference of two squares formula, what we're doing is we're going in reverse. This is not in our maths tables, so we need to know this off by heart. And it's something that we will get used to very, very quickly. So if I go back to that previous example, we ended up with x squared minus y squared times 3a minus 4b. We wouldn't get full marks for that in the exam because we haven't fully factorised, and therefore x squared minus y squared needs to be written as x plus y by x minus y by 3a minus 4b. Now, it doesn't matter the order of those brackets because remember, the multiplication doesn't matter. I can have 2 times 3 is 6, but 3 times 2 is still 6. So those brackets can be in any different order, but because we're multiplying them, we would still get the same answer out. So we're not always going to get x squared minus y squared. We're often going to get variations of this. So for instance, in the first example here, we have 9x squared minus y squared. So what we always want to do is we want to write down something squared minus something squared. So we have to spot that we have two perfect squares and a minus between it, and then that should trigger that this is the difference of two squares. So what squared gives me 9x squared? Well, it's 3x. And what squared gives me y squared? Well, that's just simply y. So if I relate that to my equation, then in the equation I have an x squared minus a y squared. So this is going to be the x term, and then that's going to be the y term. So in other words, the first term squared minus the second term squared. So that becomes 3x plus y by 3x minus y. If I look at the next one, we have 4a squared b squared minus 16c squared. So again, I start and I say to myself, what squared minus what squared is going to give me 4a squared b squared minus 16c squared. So of course, in the first bracket, I'm going to have 2ab. So 2 by 2 is 4, a by a is a squared, and b by b is b squared. And then I'm going to have 4c, because 4c squared is minus 16c squared. So in the equation, that's going to be the first term, so the x in the equation, and the second term is going to be the y part of the equation. So again, that's going to be 2ab plus 4c by 2ab minus 4c. Now in the third one there, we can see, well, 45 and 20 aren't perfect squares. So does that mean that this isn't the difference of two squares? But I can actually refer it back to type 1, where if I look at 45 and minus 20, I can see that 5 is common to both. So I can take out the highest common factor, which leaves me with 9a squared minus 4. So now I can see what's left inside the brackets is two perfect squares. In other words, I can say something squared minus something squared again. So in other words, 3a squared minus 2 squared is 9a squared minus 4. So again, referring back to the equation, well, my first term is going to be the x in the equation, and my second term is going to be the y in the equation, which gives me 5 times 3a plus 2 by 3a minus 2. So if we suspect it might be the difference of two squares, and we can't see any perfect squares, then see can you factor out the highest common factor, and hopefully you're left with something squared minus something squared. So type 4 is where we're going to have the sum or difference of two perfect cubes. So again, these are not in our maths tables, so we need to know these off by heart. So it's just a matter of practicing writing out these equations and learning them. So the difference of two squares, the sum or difference of two cubes. All three of these need to be learnt off by heart. So if I have the sum of two cubes, then it's going to be the first term plus the second term, so x plus y, times the first term squared, minus the first term times the second term, so minus xy, plus the second term squared, so plus y squared. If we have the difference of two cubes, then you'll see that the equations pretty much look the same, bar a couple of sign changes. So if we have a minus between the two perfect cubes, then it's going to be the first term minus the second term, times the first term squared, plus the first term times the second term, plus the second term squared. In other words, x minus y by x squared plus xy plus y squared. So a bit like the difference of two squares, they're not always going to be given to us as x cubed plus y cubed or x cubed minus y cubed. In other words, we have to spot that it is a perfect cube. So in the first one here, we have to factorise 8 plus 27k cubed. So there's not even an x or a y in these terms, but I can see that there are two terms and a plus between it. So therefore this is going to be the sum, and if I look at the numbers, well, I can write 2 as a cube, because 2 cubed is 2 by 2 by 2, which is 8. And then I can take the 27k cubed, and I can write that as 3k cubed, because again, 3 by 3 by 3 is 27, and k by k by k is k cubed. So if I compare that to my equation, the first term is x in the equation, and the second term will represent y in the equation. So that's going to become the x plus y, in other words 2 plus 3k, times the first term, which is 2, and I have to square that, minus the first term, which is 2, times the second term, which is 3k, plus the second term squared. And then I simply simplify that second bracket. So I have 2 squared is 4, minus 2 times 3k is minus 6k, and 3k squared is plus 9k squared. And now I'm fully factorised. In the second example here, we can see it's two terms, and this time there's a minus between it. And again, I see, well, can I write it as something cubed minus something cubed? Well, 4 cubed is 64, and 5a cubed will give me 125. So again, if you can't remember or can't figure it out in your head, you can go to the cube root button on your calculator, and that will give you the cube root of 125 and the cube root of 64, rather than guessing. So again, if I compare this to my equation, the first term is x, the second term is y. And again, if we just remind ourselves of the difference of two cubes equation there, well, it's going to be x minus y times x squared plus xy plus y squared. So that's the first term minus the second term. The first term squared plus the first term times the second term plus the second term squared. So therefore that's 4 minus 5a times 4 squared, which is 16. 4 times 5 is 20, and that's times a. And 5a squared is 25a squared. And now I'm fully factorised for my difference of two cubes. So what you're going to do now is you're going to look at the sheet that I've given out to you on your handout. And on it, we're going to mark the following questions for type 1, 2, 3, and 4. So question 2, 5, 8, 10, 12, 14, 16, 19, 22, 25, 28, 31, 32, 55, 57, 60, and 62.